Welcome to this hands-on demonstration. My name is Egon Euwe. We're going to show you today how to place a nobel replaced tapered groovy implant in a flapless situation. We have two kits, a model, an implant motor, that's the OsseoSet 200, where we have a handpiece attached. Just to show you, to start with, the nobel replaced tapered surgery kit, I'm going to show you how to open it. You flip up the cover and then you can take it off. I'm going to show you now how the nobel replaced tapered surgery kit is organized. We have the kit in front of us and we can see this neat kit has color coding. It's color coded. The drill steps go in a horizontal way, whereas the different diameters are organized in the vertical way. So we start the drilling with the 2 mm twist drill, and I'm going to show you that flapless surgery kit now. We have over here the same color code in the kit, and we have only 3 components. We're going to use the drill guide, which will be placed on top of our first drill, that's the twist drill. Then we will use a tissue punch guide and the tissue punch. They are all organized in the same yellow vertical row, so that means these diameters match. We're going to have a closer look to the OsseoSet 200 drilling machine. If we look under the display, we see a number of buttons over here. And the machine is in the drilling mode right now, indicating that the drilling will be performed with 800 RPM, which is the correct speed for drilling during this demonstration. When we step up to the next button, this is the button we use during implant placement, and you can see the machine indicates the torque. 45 Newton per centimeter is the maximum torque the machine can deliver during implant placement. But if this is too much, we can easily step down by pushing on the minus over here. Before we go to the model, I'm going to show you the components I have taken out of the flapless surgery kit. The twist drill has these black lines, like you see over here. 8, 10, 13 and 16. So with the drill guide placed on the drill, we're gonna first prepare in the right position a hole deep enough to place the tissue punch guide pin, and to do that we have to go to the 30 mm line. We start the drilling procedure like this. We bring the drill with the drill guide into position, and of course clinically we only do this when there's enough bone and enough keratinized tissue. So that's about the position mid-crestal, and now I start slowly penetrating first the soft tissue. I will go down till the 30 mm line is flat on top of the drill guide, that's over here, and I go back. The next step is placing the tissue punch guide pin into the hole we just prepared. I have it here. We push it all the way down till it sits on the soft tissue. So we can recheck the position. Distance from the neighbor tooth is correct, and also you see that the position is mid-crestal, slightly towards the palatal. We are ready now to do the punching of the hole in the keratinized tissue. The implant engine should turn with maximum 800 RPM, and we're going to punch slowly a hole in the soft tissue. When we feel the resistance of the bone, we pull back everything. So we have now a perforation in our soft tissue and we are ready for the next step. After a final check of the direction, we're gonna drill to the 13 millimeter line, and I do this by adding 2.5 millimeter thickness of soft tissue. So I basically drill just below the 16 millimeter line in the bone, and I keep the original direction. Then I step up to the narrow platform 13 millimeter drill. You see that one here, and I'm gonna prepare the site till the desired depth. Again, I want to prepare 13 millimeter in the bone, so this is why I go a little bit deeper, because we have this soft tissue on top of it. You see my movements are up and down movements. Of course we do this with irrigation. So here's the correct drilling in detail. The 13 millimeter drill goes in, and you see the drill disappears now under the soft tissue, and we have an additional 2.5 millimeter corresponding with the soft tissue thickness. So the drill is now in this moment 13 millimeter in the bone, and this is the correct depth. Now we move on with the final preparation using the yellow color coded drill. These drills are tapered, so they are self-centering, and we go with up and down movements till the correct length, adding up the 2.5 millimeter, and here we are. You see here again the black part of the drill disappearing under the soft tissue, and then we have that 2.5 millimeter extra depth for the soft tissue thickness. The drilling is completed by now. I would like to show you now how we can use the screw tab. We have the screw tab here, and if we're using short implants, 8 millimeter long, we should not exceed this line. So we use only this part of the instrument. For all other lengths we can go slightly deeper till maximum this line. Before we use the screw tab, we have to switch the implant motor from the drilling position to the slow speed, and I would use for tapping the maximum torque, and we do that with water cooling. So you can see now the instrument is turning very slowly. Now we place it in the side, stabilize it in the right direction, and we let the threads work their way through the cortical bone, and we go slowly but surely inside the preparation, creating threads in the bone. Now we've come to the desired depth, and then we reverse the directions. We are ready now for implant placement. We have indications on the tab as well as on the main package, and she let it fall onto the sterile area, and I'm ready to pick up the implant from the package. In order to do that, you can place the inner package, which is sterile, into the organizer. You can see the internal connection, and with the implant driver, in order to click in the connection, you can make a turn, and now we have the implant ready to be placed into the model. With the motor in the implant insertion mode, with a torque of 45 Newton, we are ready now to place the implant in the model. See, we start slowly, light pressure, and the implant will be self-centered. It's almost enough to place the implant completely into the site. To do the last couple of turns by hand, we remove the implant driver from the implant, and we're gonna place the driver now in the manual torque range. Manual placement of the implant and final seating of the implant is done by placing the implant driver into the manual torque range, and you can see here the implant still not being completely seated. It's now flat with the soft tissue level, so we're gonna turn the implant deeper into the site. During this final stage of placement, you can see the torque building up on the torque range. There's another thing. If you go too deep, you can back up by turning this little arrow at the end into the opposite direction. You can unscrew the implant the way I'm showing you now. So, to place the implant, only touch the little knob over here. We do that by placing one of the lobes of the internal connection towards the buccal plate, and that's indicated by this vertical line on the implant driver. I remove the implant driver, check the depth, and I'm just above bone level, let's say 0.5 millimeter, and the lobe facing towards the buccal. If we want to do now single stage placement with delayed loading, we would normally place a healing abutment on the implant in order to be able to do the prosthetic procedure some weeks later. So the Unigrip driver is the tool to place a standard healing abutment on top of the implant. Another option would be, if we want to go for immediate loading on an implant which is stable enough for that, to use an immediate temporary abutment. We see that here. The immediate temporary abutment is being applied with a multi-unit driver, which we can use by hand, as you see here, but that multi-unit driver also fits on the manual torque wrench. The idea is never to exceed the insertion torque of the implant by torquing this component till approximately 35 newtons on an implant with a primary stability of 35 plus. This immediate temporary abutment comes with a little plastic cap that will be picked up by rebasing the provisional with a small amount of acrylic. We have seen now flapless implant placement on a model, and to translate this into a more clinical situation, I think we can conclude that with proper diagnostics and treatment planning, a flapless surgical procedure is a non-invasive procedure, and combined, for instance, with immediate function, a very good and comfortable option for your patient. So, thank you very much for your attention.